Hey everybody, this is Miss Manili, and I'm going to be going through the review for the first part of our Unit 2 assessment. I've broken it into two parts because I wanted to make sure that you had another opportunity for an assessment before the end of the marking period. And so I've broken it up and I'm calling this modeling. The actual unit is all about exponential and log functions, but because we haven't really had a chance to investigate those functions, I'm just going to focus on the modeling part of the unit at this point. The first thing we did in this unit was talk about series and sequences, which is basically lists of numbers. There may or may not be a pattern. We focused on two particular types of patterns, the arithmetic sequences and the geometric. We defined an arithmetic sequence as being the type of sequence where you have numbers where there's a constant difference or a common difference, and where we're either adding or subtracting the same number over and over again. With the geometric sequence, that's where we're either multiplying or dividing by the same number, and we call that the common ratio. You will be given a formula sheet on the assessment, so you do not have to have these formulas memorized, but you do need to understand the notation. So you need to know what a sub 1 means. You need to know what a sub n means, what a sub n plus 1. What all that means, you need to know. So in the first one, you're given a sequence. It's 648, 636, 624, 612. I'm looking at that, and it looks as though I'm adding, it looks like the numbers are getting smaller, and it looks like I'm constantly subtracting something. So the easiest way to figure out your common difference or common ratio is to always start with the second term, and so in this case it's 636, and I'm going to start with subtraction, and I'm going to subtract my first number, 648. And I get the number negative 12. So let me do the next one, 624 minus 636. Notice I also get negative 12. And let's try the last one, 612 minus 624. And I got negative 12 again. So that tells me that this sequence is an arithmetic sequence because I'm constantly subtracting 12. So if I'm constantly subtracting 12, that means it's arithmetic, and my common difference is going to be negative 12. Okay? I can also tell with this sequence that my first term, which I'm going to define as a sub 1, is 648. Let me just fix this so it looks more like a D and not an I. There we go. All right, so it asks us to write a recursive formula for the sequence. So I'm going to go up to my formula, and I'm going to look under arithmetic. I'm going to look under recursive. So notice that there are two parts to the recursive formula. You need to identify your first term, a sub 1, and so my a sub 1 in this case is 648. And the second thing I need to do is describe the next term in the sequence, which is going to be a sub n plus 1. We use that to say the next term. Well, the next term in the sequence is always defined by the term in front of it, which in this case would be a sub n. And then I'm going to add my d. Well, in this case, my d is negative 12. Now, please note that the next term in your sequence could also be denoted as a sub n. If that's the case, then the term that comes before that is going to be a sub n minus 1. And then to find the next term, I'm just going to subtract 12. So notice that these two formulas here mean the same thing. They're just written differently. So if you have a multiple choice problem, or if there's, a matching section, you want to make sure that you recognize that these two formulas mean the same thing. The next problem is asking you to write an explicit formula. That would be this formula here, where we're just trying to find the formula for any term in the sequence. Well, just like with the recursive formula, you need to tell in the formula, you need to know where it begins and how it's changing. So both formulas do that. The recursive formula does it in two parts. The explicit does it in one. So for the explicit formula, we're going to have a sub n is equal to, and notice that I'm going to start with my first term, a sub 1, which we already know is 648. And then I'm going to add d. Well, in this case, my d is a negative 12. So I'm going to, instead of I'm adding a negative 12, I'm just going to subtract 12. And then I want to multiply that times n minus 1. And that's all you would do for your explicit formula. If you want to determine the sum of the first 15 terms, now this is something that I didn't show you a shortcut in class because technically you're not assessed on the sum of an arithmetic sequence, but just to kind of show you, this is a new formula. And essentially what you're doing is you're taking the average of the first and the nth term, which in this case would be the 15th term, And when you add them and divide by 2, remember that's just an average, and then multiplying by n, which is just the number of terms in the sequence. Notice also the notation here. S sub 15 is essentially what we were calling the sum from n equals 1 to 15. And if we use our explicit formula, that would be 648 minus 12 times n minus 1. So this notation is the same as what we were using, what we were calling summation notation. It means the same thing. We want to add the first 15 terms together. So you can either enter the formula into your list and write down the first 15 terms and then add them all together, or you can use the shortcut formula. And like I said, the shortcut formula isn't going to be something you're going to be assessed on, but I figured I'd go ahead and show it to you. So what you need for this formula is the value of n. Well, how many terms are we adding? We're adding 15 terms. Our a sub 1, well, we already know that. That was in our formula. We know a sub 1 is 648. And then a sub n would be that 15th term. So I need to figure out what my 15th term is. Well, I can use my explicit rule to help me find that. If I take 648 minus the 12, and then since I'm finding the 15th term, I'm going to have 15 minus 1. And if I simplify that, I can do that on my calculator. 648 minus 12 times 15 minus 1. And I get 480. So if you were to plug this in on your calculator and plug the explicit rule into your calculator and scroll through and list the first 15 terms, the 15th term should be 480. So what the formula for finding the sum is asking us to do is to basically take the average of the first term and the 15th term and then multiply it by 15. That's all it's asking. So n is 15. My first term we said is 648. My 15th term is 480, and I'm going to divide that by 2. That's just an average. So when I plug it into my calculator, 15 times 648 plus 480. I'm going to close out my parentheses before dividing by 2. And so the sum is going to be 8,460. And that would be it. All right. The second problem is very similar, except this time our sequence is going to be geometric. You can kind of guess there. And if you look at the numbers, we're going from negative 18 to positive 12 to negative 8 to positive 16 thirds. So it may not be obvious to you how these numbers are decreasing, especially since the sign is changing. And so again, to find that common ratio, I'm going to take the second term, which is 12, and I'm going to divide it by the first term, which is negative 18. And I get this decimal. Notice that it keeps going on and on and on forever. I want to avoid rounding, because if I round, then the sequence isn't going to work out perfectly. So if you get a decimal like this, hit the math button, and then notice that the first option will change it to a fraction. And so that means that the ratio here is negative 2/3. I do want to make sure that it works for all of them. So I can either do negative 8 over 12 and then do 16 thirds over negative 8, or I can just test it. So if I do this, if I start with negative 18 and I multiply by negative 2/3, oops, divide, sorry, that gives me 12. If I multiply that by negative 2/3, I would expect to get negative 8, and I do. And if I do the same thing, in fact, I can just hit enter again, I get 5.333. So I want to know if that's the same thing as 16 thirds. If I change it to a fraction, I get 16 thirds. So I can tell that this sequence is geometric, and I know that my common ratio is negative 2/3. I can also tell that the first term is negative 18. And those are the values that I'm essentially going to need for both of my formulas. So now if I'm doing a recursive formula, if we go back to our front page where we have the recursive formula, I know with the geometric, again, I need to identify my first term, and then my next term is just the term before it times my ratio. And so that means my first term, we already know, is negative 18. And then to find the next term, and if I call my next term n plus 1, it's always defined by the term in front of it. So the term in front of a sub n plus 1 is just a sub n, and then I'm going to multiply that by my ratio, which is negative 2/3. But remember that the next term could also be written as a sub n. So if my next term, if I'm calling that my nth term, the term before that is going to be a sub n minus 1. I have to go back 1. And then I'd again multiply by my ratio. So just remember that both of these equations represent the same thing. And so you want to be able to recognize your explicit rule either way. I'm sorry, your recursive rule either way. When it comes to the explicit rule, it's always going to be a sub n because we're looking for the formula for any term in the sequence. And just like with the arithmetic, both formulas include something about where the sequence begins and how it changes. With the recursive rule, we do it in 2 statements. With the explicit, we combine them into 1. So if I go back to my formulas, if I'm looking at my explicit rule for the geometric, it's where I start times r raised to the n minus 1. So in this particular case, we started with negative 18. Our r value is negative 2/3, and I'm going to raise that to the n minus 1. All right, if I'm going to determine the sum of the first 28 terms, this is the same thing as if I were to say n equals 1 to 28, and then plug in my explicit rule. So that's what this means. Okay, and so we have a formula. This is a finite sequence since it ends. We're stopping at 28. So if I go back to my geometric rules, the sum of a finite series, okay, that's the formula I want. And notice I need 3 things. I need a sub 1, I need r, and I need n. Okay, so in this case, my n value, since I'm looking at the first 28 terms, is going to be 28. And so according to the formula, I'm going to multiply by, I'm going to start with my a1, which is negative 18. And then it's going to be 1 minus r, or 1 minus, now I have to be careful because r is written as a fraction, so I'm also going to want to make sure I put that in parentheses. I need to raise the r value to the nth power, which is 28. And then I need to close the parentheses for my numerator before dividing by 1 minus r. And again, I'm going to put my r in parentheses. You must be very careful when you enter this into the calculator because if you forget a parentheses or if you accidentally make a mistake, your answer is obviously going to be wrong. So it'll be very important that you write this out on your paper so that I can at least give you partial credit for setting it up properly. So let me show you how to set it up, or how to enter it on the calculator. We're going to take our negative 18, and then I want to have parentheses around my numerator. So it's going to be parentheses 1 minus, I want to make sure I put my fraction in parentheses always, so negative 2/3. And the negative is going to go on the inside. I'm going to close out my fraction before raising it to the 28th power. Now be careful if you have one of the new calculators, you got to pull your cursor out of that exponent before closing off your parentheses. So that's your numerator, that's what you should see. Now I want to divide by 1 minus the quantity negative 2/3. Your denominator must also be in parentheses, otherwise it's just going to take the top and divide it by 1. Get an answer and subtract 2/3, which is not what we want to do. So I'm going to do 1 minus, and again, since I'm subtracting a fraction, I want to put parentheses around it, negative 2/3, close out my negative 2/3, close out my denominator, and so that's what your denominator should look like. When you press enter, you should get a sum of negative 10.79987, or negative 10 that's going to actually just round to 8. I like to see at least 3 decimal places though, so I'm going to write it out. Negative 10.799, that's actually going to round to 9. Okay. So these first 2 problems deal with sequences and a review of sequences. So I'm going to stop here and call this the take 1 of our review.